So hi everyone, welcome back to my channel. So this is the first video of my channel, Nobita Fan Club. So in this video we are going to discuss Leetcode weekly contest 382, and I was able to solve first three problems in the contest. So I'm going to discuss these problems. So let's start with the first problem. What is the first problem? In this problem we are given a string, and what we need to return in it, we need to find the number of times user had to change the key. So basically what the problem is saying, that we need to find number of pairs, like number of adjacent pairs which are not equal. Like we have to find number of characters which are adjacent, and these characters should not be equal, whether one of them is in small case or uppercase. Like as you can see in this string B, like the first two characters both are B, one is uppercase and lowercase, and the second and third is also both are in uppercase, and similarly third and fourth, one is uppercase and one is lowercase. So in this string we need to return 0. So this is the problem. It is a easy problem. So let's see the solution of it. So what I did, I started from 0 to s dot size minus 1, because I can't go up to s dot size, because I am checking to s is equal to s I plus 1. It will give me runtime error if I go up to s dot size. So what I am checking s of I minus s of I plus 1 should not be equal to 32. Basically the lowercase of small a is 97, and the uppercase of capital A is, I think, 52 or 56, maybe, I don't know. At this time I just google it, and the difference between both of them is 32. So what I am doing, if the difference of both of these is 32, basically its difference will be 32. You can check it. I have already checked it, so that's why I'm saying, if this difference is 32, then we can't say that it will be plus plus. So I'm checking if it is not equal to 32. And also one more condition, if both the characters are of same case and are equal, then it will be equal to 0. So if these two conditions are not present, then I will count my counter plus 1, otherwise I will not count, and then finally I will return my count. So this is the problem solution of this problem. Let's see the next problem. So it is a little bit a confusing problem at the time when I read it. So what the problem is saying, you are given an array, and we need to select some elements of the array such that when we create a new array of those elements, then that array should satisfy this property, this pattern. Like for example 2 4 16 4 2, like here the power of 2 is 1, then 2 into 2 equal to 4, and now 4 into 4 equal to 16, and then these two will be placed here, and similarly here 3 into 3 will be 9, and 9 by 3 will be 3, so it will come here. So these are the examples of our following pattern, and it is not that, because 2 into 2 equal to 4, and 4 into 4 should be 16, not 8. So it is not our final array which we need to find. So here what we need to return is, we need to return maximum number of elements in the subset. Like we need to create a subset such that in that subset the number of elements should be maximum. So what I did in this problem was, like first of all I use the map. If you don't know what is map in C++, then you can just google it. You will find a good tutorial on Geeks for Geeks, where you can read about map data structure. So here I am using map, and I am counting the frequency of all elements, because the pattern should be of this format. Here so the count of 2 should be greater than 2 if I need to take them, and similarly the count of 4 should be greater than 2. So that's why I am using map here. So no, the use of multiset is nothing, so I can remove it, and I have also not used in my solution. And Initially, the answer will always be minimum 1 because one element will also satisfy the property. Here you can see 1, 3, 2, 4. I can take any one of them and my answer will always be at least 1. And here the value of answer is mp of 1. Why I am doing it initially? Because if I take 10 9m 91, then what will be my answer? My answer will be 9 because I can place first 4 1 in the starting and last 4 1 in the end and 1 1 in the middle of them, because whatever we do, the power of 1, that will always equal to 1. So that here the value of answer is mp of 1. And if the if the frequency of 1 is 10, because I can't take 10 because our final array should be of odd size. Here you can see from this pattern is saying our final array should be of odd size. So that's why we have to make our answer minus minus. And after that I started in our map, and if our value of if our first element is 1, then we will continue because we have already put that in our answer. And now if it can be removed because it's not required. And now we will checking. No, it's required, I'm sorry. In the first time it is not required, but after we will do value into value, it will be required. So if we are checking the frequency of value is greater than 1, then we will count our value and we will make our value into value because we need to find that pattern. And if the value of like, it can also be removed because we have already checked it. And we will continue it until our value is not present in map and their frequency is not greater than equal to. And now we are checking if our map dot find val not equal to 0, like say I have come 2 into 4 and 4 into 4, let's say 16 is not present in the array. Then if let's say 16, this condition is saying that 16 is present in our array, and this condition is saying 16 is not present, because if 16 is not present, then we need to return from here to like 2 4 4 2. We can't count 16. If 16 is present, we need to make it plus 1, otherwise minus 1, because we can't take 16. 16 is not present in our array, and then we will initialize our count again to 0 because we have to find the maximum answer. So that's the solution of this problem. It's accepted. So now let's move to the last problem, Alice and Bob playing flower game. So in this problem, what you have to do, we have given Alice is present at one point and Bob is present at another point, and there is a circle on which they are present. So the circle representing the field, and there are X flowers in one side of them in clockwise direction between Alice and Bob, and Y flowers in the anti-clockwise direction between them. So how the game proceeds, it's given Alice takes the first turn as always. In each turn, a player must choose either the clockwise or anti-clockwise direction and pick one flower from that side. So either Alice or Bob can take any flower from any side, but whether it is anti-clockwise or clockwise, it doesn't matter. At the end of the turn, if there are no flower left at all, let's say there is one flower at one side and another side 0 flowers, and let's say it's a Bob turn, so Bob can take one flower from that side. And now if there is no flower in both side, then the current participant will win. Then the current player captures their opponent and win the game. This is the condition of winning. And what is given in it, we are given two integers n m n. The task is to compute the number of possible pairs x and y that satisfy the condition. So we need to find uh, number of possible pairs such that Alice win the game according to the described rules. And the bounding of x is the value of x will be lie in the range of 1 to n, and similarly the value of y is also lie from 1 to n. So this is the problem statement. We need to find the number of pairs, possible pairs x and y such that Alice will always win the game. So let's see this problem with a simple test case. Let's say there is a one element at one side and one element at the other side. One floor at one anti-clockwise, one floor at clockwise direction. So Alice starts the game as always. So Alice will can take one flower from any side. Let's say it has taken one flower from clockwise direction. And now the turns of Bob come. Bob will take, obviously there is only one flower left in anti-clockwise direction. Bob will take that flower. And now Bob will check there are no flowers present at both of the sides. So now Bob will capture Alice and Bob will win. So what is the observation here is there is one flower at anti-clockwise and one flower at clockwise, and the sum of these number of flowers is 2, which is even. So what we can say, if the number of flowers is even, the sum of flowers anti-clockwise plus clockwise is even, then in this condition always Bob win. And if the number of flowers in both sides are odd, then Alice will always win. So this is the solution. Our answer will be n plus 1 by 2. This is the formula which I generated, and this is the solution. You can understand it by yourself. So thank you guys. This is the all solutions that I solved during the contest. So thank you guys. Bye bye.